Hello, hello. Oh, Eduard is twice there. Wow.
Oh yeah, I had to leave because I couldn't hear the audio, and I came back and I'm still there. No why.
And then now you are connected twice. So we got more participants. That's great.
I'm growing bigger.
Yeah. So hello again. And after the lunch break and after the COVID test break, so we'll continue with the topic syntax representations. And maybe I start in another way. Look at that. A lot of boxes, a lot of arrows. So this is just one class in the sender, the conceptual variable. And yeah, there are a couple of associations, the arrows, the lines with the open arrows, and a couple of inheritance relationships, the lines with the closed arrows. So basically you see here all the fundamental UML items we are using in the model. No? Above the concept, no? So the conceptual variable inherits from the concept, but also has some additional association. The concept has a couple of class attributes, and that's more or less the core set of UML items we are using. We are using a couple of more, but regarding a syntax representation, you need to think about these items, no? To map them to the target language. No? The target language we worked already on is XML schema. No? So there is an XML schema representation of the DDI-CDI model. Eric Prudhomme worked for us some time ago to create our RDFS representation without using other vocabularies. That's the restriction of this, but I think it's very mature. No? Now, with the opportunity of your presence here, Pierre-Antoine, I think we would like to look into JSON-LD and a representation of JSON-LD. And that's could be, ideally, that would be the goal of this week, no? To achieve a JSON-LD expression, either as a transformation from OWL RDFS expression or directly. I think you talked about that a little, and I missed that. I'm sorry about that. So I will look at your presentation to be up to date. Also, yeah, it would be nice to have a JSON schema or other means for validation purposes of an instance of JSON-LD to make sure that the relevant. Okay.
It's not that your stomach doesn't look good.
Better? Okay. Now I see the point that I should stay there. Okay. What else? Yeah, basically the mapping process, it's on two levels. No? So the conceptual meaning of the UML items, no? And how to map them to the target language. Stata could be also a target language. I told you Larry Hoyle and I did representation of a previous version of this CDI model. No? It's just a prototype. No? And the next would be, on a detailed level, a mapping from XMI items to the target language. XMI is an XML expression of UML, or could be understood as an XML expression of UML. XMI is created by OMG, which did also UML. XMI is very expressive, but it has a couple of issues. No? It's basically too expressive, and the UML tool vendors misused this expressivity. That means when you create a UML model in one tool and try to import it into another tool, usually that doesn't work. No? OMG answered basically on that a couple of years ago and built the canonical XMI expression, which is basically a stricter rule set for the XMI. And at least all the relevant UML tools can import a canonical XMI impression of a UML model. The export is still an issue. No? Anyway, we have chosen the canonical XMI to express our UML model. So we are talking here this version of XMI. And basically, after the decisions on these items, UML items and XMI items, which could be captured in a spreadsheet, in a table, in addition to that, additional document would be necessary to capture any exceptions, no? Any issues with the mapping process. No? And how do these spreadsheets look like? It's hard to read, that's my impression. Yeah, that's it. So there are a couple of columns. So one is the type or the category, and which, so the group of items. No? Packaging, for example, no? There's a UML model, there's a UML package, and how to map this to the target language. There are classes, there are attributes or properties of classes, and then there are relationships, associations, but also the inheritance relationships, called in UML generalization. So the superclass is the generalized class in relationship to the other specialized class. And then there are data types, structured data types, which can be complex, so they are using other data types, or a more simpler one, like enumerations. It's just a set of named values, or primitive types. No? And UML knows only a very small set of primitives. And that's basically it. And on the right-hand side, you see currently empty space. So the goal would be to capture here some ideas on a target language, like JSON-LD, or we can have a look at Eric Prudhommeau's draft mapping to OWL RDFS. Here, it looks a little more complicated, but these are the XMI items. No? And they are often repeated, like a comment, our own comment can stay anywhere, and names and things like that are also repeated. But on a programmatic level, you have to focus also on these items. Otherwise, a mapping wouldn't be possible. Ideally, a mapping would say, oh, this UML item is equal an item in the target language. And often this is possible because UML, the part of UML we are using is basically an object-oriented approach. No? And all the languages which use a similar pattern can be expressed with that. We learned, for example, that most of the items can be mapped to OWL RDFS, but UML knows associations and also aggregations and compositions, which are specialized associations. This is apparently not common in RDF land. No? That means basically it would be just a comment, no? in this target language. No? I think this is an issue with also a lot of object-oriented program languages. I think Java does not make really in a basic understanding, not a distinction between an aggregation and a composition. And I have to say, just to confuse you, in UML, there's a huge discussion on the meaning of an aggregation. Is this necessary or not? No? And we are using it only basically for documentation purposes, no? But not to express any further semantics on it. No? So, yeah, existing mappings. XML schema, there is a document from Oliver Haupt and this gentleman, and also XML schema expression. And and then there's this draft mapping on OWL RDFS. That's it, basically. What did I do? Okay. Going back to that. For each class in this kind of documentation, there's also on the button this tab. Yeah, here you see a canonical XMI expression, and here the XML schema expression of this class. It's just has here documentary purposes because the use of a single class in XML schema is a little limited, but it just shows how this works. No? And here could stay, yeah, there could stay more syntax representations. That's basically it as an introduction to this, and as some background we have work on. So Darren, please.
Yes, you mentioned, sorry.
Yeah. Thank you, Knut.
So you mentioned, Arafan, earlier about if you want to link into SCOS, for example, you can do. So here we have a good example where you've got a concept class, which is a proprietary class within DD-CDI. In terms of expressing how you could actually link, could you just link that conceptual variable class to the SCOS concept class by reference? And if you did so, how would you kind of express that within the schema itself?
We haven't completely figured that out yet. I think within the CDI model, there is a concept. In a generic mapping, which is, I think, what Akim is really talking about here, something we would publish as the Alliance alongside the spec, you would map it to, the concept would be a concept in CDI. In an implementation, you might decide to do that differently. One of the expressive capabilities of our class in our model is the ability to simply reference an external class and say this concept represents that one over there in that other language. And I actually think that is probably the easiest way to incorporate other standards into the model. Something we've been doing with standards alignments is putting in the original version of the model, they were trace relationships. That might be somewhat different in the production version, but we would have classes from other standards traced into classes in our model. So we can say this process step is a Bravo process step, right? And have those relationships formally in the model. But that means having native, if you will, object classes in our model to represent those things. So I think that's probably how we deal with it. That's what we're thinking now. Again, that's not cast in stone. So we could decide to recommend something different here this week.
Yeah, I think it's also the question. I think my introduction showed more a generic approach, how to map the whole thing on a more technical level to a target language. And when you think only on a part of the model, that might be useful, but often if the target, like SCOS, is something not just a technical language, but some conceptual approach, then there's further thinking necessary. So, and also I think that touches probably a little the topic implementation guides. Maybe you talked already about the relationship. No? If the target language is used from a specific user audience, user group, it might make sense to combine the thinking in an implementation guide and also on a technical mapping. No? But that's a little open question. I think we will learn more about that. No? So more questions? No questions so far? Okay. Yeah, you?
More than a question, some thoughts on the, yeah, I don't know if I'm facing that camera or whatever. So to quickly summarize what you missed this morning in my presentation and about the slide you presented, so as an alternative between doing an RDF mapping and doing a JSON schema, actually my proposal was to do both and then have a JSON LD context ensure the mapping between the two. Now, what I find interesting in this methodology is that we would have both mapping defined in terms of correspondence, a mapping to the conceptual UML classes, or not just classes, but all those concepts. And so to answer what Edouard, I think, was saying this morning, then maybe this pivot conceptualization could be used to help us maybe even, let's dream, automatically generate the context between the RDF vocabulary and the JSON schema. Thing that, again, I've been thinking about a lot recently, because that's the kind of thing that you would like to be able to do. Maybe you have a good example here of a methodology that would allow us to do that. So I think it's really interesting in that respect.
Thank you, Antoine. Yeah, that's good to know. No? And so, Edouard, do you have any comments or questions? I guess you did already probably also work on some mappings from UML to any target language. Am I right?
Yeah, and I always, yeah, the same I was mentioning before, and sorry, I'm bad with names. Pierre-Antoine, what you just mentioned, the idea of a pivot of some. To me, when I was mentioning a context, and sorry, and I guess we are all still a bit fuzzy on the words we use, but I would see the idea of the context as a way to parameter the pivot between the two languages, be it like RDF OWL and JSON schema, or between a JSON representation of the DDI and target language. So I don't remember implementing anything that kind of automating this discovery of a pivot, which sounds challenging, but it's at reach in some point. I don't know in a week what we can do or what we can expect from the outcome of the week, but if we could define what it means. To me, defining the pivot means that we already understand what is the difference between the two languages in their structural information, but also in the way they have been made up and the profound differences between them. So it's something that to me can be very valuable to understand.
Okay, thank you. Any more comments or questions? Knut, can you think on any target language syntax representations you especially would be interested in? I know you are working a lot with data and also R.
I'm really not sure if whether Stata or SPSS or R or some similar statistical packages would be an appropriate target language for this. That's for me a question. If I think about the language of Stata or SPSS, I think about the code I write for analysis, for statistical analysis, and not so of I don't see such a near relation between those two worlds at this moment.
Yeah, I think that's a good point, no? And there should be always a reason to do that, absolutely. And R and Stata are mainly analysis packages. No? It might be a little different with R because people are adding a lot of stuff into the R language. And so the thinking of Larry Hoyle and myself here was that it might make sense, no, to add more or less the whole DDI CDI as a package to R, as a basis, as a building block to build some in addition to that, like that data management, metadata management, and analysis are more glued together. No? Because currently you are doing in one package your analysis and then exporting something. Yeah, how do you achieve the resulting metadata? No? The idea was that a CDI package in R could help to capture the generated metadata, basically, not only the data for the analysis results, and then to transform it immediately to either to export it or to what else. No? That was the basic thinking. No? And also the other way around, in case you are doing more, I think it makes more sense in case you are doing more automated analysis. No? You are consuming some data and metadata resource, and then building some combined data set, and based on the data and metadata, you're doing some analysis. That would be the other perspective. No? There's still the question, is this not too much asked from the R user? No? Because it only would make sense if on top of such a CDI package, a user-friendly data and metadata management and analysis package is. So basically, an interface is available, and we were thinking on some graphical user interface. Otherwise, I think it's probably too complex. But I would be interested to hear more comments on that, because I think your comment, does it really make sense? No? Is a valid question, absolutely. And we were more thinking on R. Data is I think it would be, because it's not open source, that's one argument. The other is, I think, it's now very common to do all these things in R. No? So. Are there other R users here in the round? No? Okay, only you.
If one wants to do this and what happened?
There's a message from Eduard.
Okay.
The audio.
Oh.
Light green or dark green?
What would you say?
Dark green. Eduard, can you hear me? Eduard? No, we can't. He can't hear us. Can you write? Can somebody write, Eduard? In the Zoom chat? Okay. So Erofan is doing.
We talked about combining different data sources, and R function which combines different data sources is merge, as in data, and it joins two data sets more or less by some key variables, and would this be, or other question, how would this look like in DDI, CDI, the merging, joining of two data sets? Is this?
I think that. Oops.
Yeah, but I mean, the mic thing is showing some lemons down there, and also the mic symbol in the Zoom is showing lemons when you speak. So
I'm asking on the chat if anybody else can hear him to see if it's a general problem. So just keep going.
just keep going, because I think it's
Yeah, I think CDI just provides the way to combine multiple sources in a combinable way. No? But the combination has to be done by thinking on R. You have your data and metadata sources on this level, and then described by CDI, which would be a kind of common language for the different sources. And then on top of that, you have to do some operations like transforming or combining the data, comparing the data, and analyzing the data. No? That would be the thinking. No? Because CDI alone doesn't do anything. No? It's just a description of something. No? It's no activity. No? What you could do, thinking further, now it's getting more complicated. We were currently just talking about the data description part of CDI. There's the process description part. You know? At least in theory, you could describe the steps which combine data in advance, no? And then operate on basis of these descriptions and doing some computational stuff, no? Or even some analysis. No? That might be another way, but that's very thinking in advance. No? So. But back to the mapping. Who has some experience in mapping formal languages? You? English to German?
Broken German.
Broken German? No, formal languages. Not natural ones. You? Which kind? I would be interested to hear.
Actually, I just say kind of because I'm trying to find a concrete example of things that I did that could map into this. But I got the intuition that by digging I could find some. Well, one example would be the current work on RDF stars semantics, which at the moment is done by a mapping from RDF star to plain RDF. That's two very close languages, but still a formal mapping. Yeah,